to our community meeting. So we're going to start with a Fluentcon recap from Anurag. And with that, just go ahead and get rolling, man. Stop my share.
Excellent. Thank you so much, David. Hey, everyone. Anurag Gupta here, one of the co-founders of Calyptia. And a few weeks ago, I had the pleasure and opportunity to be part of a Fluentcon, which is a conference around the two open source projects, Fluentd and FluentBit. They're part of the Cloud Native Computing Foundation, and they help users who are trying to collect data and send them to destinations like OpenSearch. So formally, earlier this year, OpenSearch and Calyptia, which is the company I'm part of, behind Fluentd and FluentBit, we partnered together to make sure that we support these projects really well from an open source perspective, as well as from a connector standpoint. So we built Fluentd connectors and we built FluentBit connectors. If you go on the OpenSearch blogs, we have a couple of getting started guides, and you can already start to use that. So Fluentcon Europe is our user conference for these two projects. And this year we had some really nice participation from the OpenSearch community. And so we had a number of sessions presented by folks at Microsoft, Medtronic, Asana, and even the OpenSearch project team talking a little bit about a logs analytics use case. And so I thought I would just spend 2 to 3 minutes here letting everyone know how things are going. And similar to this community meeting, everything was recorded and available online. So you can find a recap. We transcribed everything, and everything's available on YouTube. So you can kind of watch everything at your own pace. There's also a session we did that was more general about the Fluent projects, along with two other very popular observability projects, OpenTelemetry and OpenMetrics. And so you're more than welcome to go see all that. Even the OpenSearch keynote is all there. So kind of the at least 3 takeaways I thought I could share from the conference that I thought were really interesting is a lot of folks are starting to look more at observability data collection. So we had about 40 people, 50 people in the room, about 100 or so online. And we could see this growing trend more so this year than previous years, where people are starting to say, hey, I'm trying to do logs, metrics, traces. I'm trying to figure out how I should go collect this data, how I can reduce that data, how I can add some enrichment to that data, especially as it comes from sources that are more container focused or ephemeral. And so we had a lot of really, really good questions coming there. And I was super excited to see a lot of folks from the OpenSearch community participating in Fluentcon. We had a couple of questions coming about, hey, I'm looking at a Beats migration to FluentBit, Fluentd. What does that look like? And also a lot of folks who had just come from kind of the ELK side of the community, where they'd been using open source Elasticsearch for logs analytics use cases, and now want to say, okay, how do I go about using this with OpenSearch? So I think there's a lot of good content that we can create there. We did a lot of workshops at Fluentcon, most of which are still available online. And so now looking at how can we bring some of those workshops to these two use cases. And then the last one, just kind of a more general thing, we introduced metrics as part of FluentBit. So Prometheus style metrics, Prometheus pushing metrics last year. And we started to see a lot of folks who were starting to pick that up. So we're excited to, especially with some of the new features coming in OpenSearch around the Prometheus piece and everything, on how we can start to mesh into that world and help give folks this really nice end-to-end experience. So with that, I'll go ahead and stop sharing. It was just a really quick recap. I think the recordings and these slides, by the way, will be shared right afterward, are going to be the best place if you're interested in exploring. Watch at 2x, 3x speed, all good stuff there. Let me go ahead.
Thanks for
any questions.
Yeah, any questions? I just dropped that link in the chat so everyone can bookmark that off, and as well you can see the slides when they get shared out.
Okay, awesome.
Cool. Thank you so much for sharing and taking the time. I'm actually really looking forward to getting into, like you mentioned, the Prometheus. I actually just started a project yesterday working on that, so super excited to start digging in.
Awesome.
Yeah.
Okay.
All right. With that, Thank you for your time, Anurag. And we're going to now hand it over to Tuana, who's going to be talking about bringing NLP to OpenSearch with Haystack. So this one is super exciting. We don't have a lot of NLP content coming through. We have a lot of observability stuff. So with that, take it away.
All right, let me start off by sharing my screen and introducing myself. So hello, everyone. I am Tuana, and I am the developer advocate at Deepset for Haystack, which is our open source NLP framework. And actually, David inspired me to come and talk about this with you guys today, because I know it's probably not something that comes up a lot in these community calls, but we had a brief chat the other week where I showed him what you can do with OpenSearch and Haystack, and he thought it might be a good idea for me to share it with you guys. So I will start explaining. So you can find us on Deepset.ai. So Deepset is the company, and the open source NLP framework is Haystack. And I was initially going to, do you see the second slide? It was a bit laggy for me, weird, but
we can see.
Yeah, I'll actually start off with the following slide though. For some reason, it's coming up like really late for me while I'm sharing the screen. So I want to talk about question answering and how you can bring question answering to an existent OpenSearch database, for example. And specifically, I'm going to talk about extractive question answering and why we refer to that as a search problem. And to explain that, I've been starting to use this little image I made the other week. So question answering models, what they are actually trained to do is look or search for answers in previously unseen data. So you can have a bunch of documents that a question answering model hasn't necessarily been trained on, but an extractive question answering model will be able to sort of look through that context and grab the answer. So it comes in two main steps we refer to, which is finding the relevant documents that the answer might exist in to the question you asked, and then following that, find the correct answer in those documents. So actually, OpenSearch comes in play in the first step here, because Haystack is built on this idea of pipelines, where you have nodes that are designed to do certain things. And the idea is you can sort of mix and match those based on what you want to achieve. So for question answering, we usually follow this structure, which is first a retriever, and that's where OpenSearch will come in. And then a reader, which is what we refer to as the question answering model. So the question answering model we generally refer to as the reader. And what's cool about this structure is extractive question answering models are generally very limited by input size. So if you have a retriever before it, you can sort of limit the amount of documents it has to look through to find the answer. And this is where we use document stores, and this is where OpenSearch gets used a lot as well. And I have a demo to show you. So first off, like we're here. This is where OpenSearch comes in, and let me show you an example snippet of code. So the reason why I want to talk about it now is because we have the capability in Haystack now to reuse a pre-existing OpenSearch database. So if you use OpenSearch with any sort of text data, or if you don't yet, but this sort of inspires you to try it out, it's literally these few lines of code. You can make it even simpler. I'm doing some fancy stuff here, to be honest. But you can say OpenSearch index to document store and pull pre-existing text data into another index, and then you can do some fancy stuff with it. For example, you can create what we call embeddings or text vectors from all that text you have. And then you can declare what type of question answering model you want to use. This is what we declared in the farm reader bit. I don't know if you see my mouse, but then you get a reader. And then you use both of them in what we call a pre-made extractive QA pipeline, and then you're done. So you can then say pipe.run. This is an example of a question answering demo where the OpenSearch index has Game of Thrones data. So I've got all of my documents about Game of Thrones in there. I've not had to retrain or fine tune my model. And then I'm just asking who's Cersei married to, and then that's it. So I'm actually going to stop sharing this screen, and hopefully I'll be able to switch to the other one quite quickly. Let's see, where is it? Yeah. Hopefully you're seeing a Colab notebook.
Yep.
Are you?
Coming through.
Yeah. Yeah, so I already ran the previous steps because some of them take some time. But now we've got, hopefully it's still there, but now we've got this pipeline already ready. And I asked, who is Cersei married to? And you got the answer, Robert Baratheon, and you can get some more information about what document it found that answer in and how confident of the answer the question answering pipeline is. And we can try something else. Who is Arya's father? It would be quite sad if it doesn't get this now. I'm showing it live, but let's wait for it. Yeah, you kind of have to wait for the inferencing, and also my machine isn't the best. And there we are. So you got the first few answers, and actually the first two, if anyone knows Game of Thrones, are actually the same person. So this is quite good. So it's most confident about Eddard, and then the second answer is Ned. And all of these documents, I think they were scripts from the TV show. So you can see which season, what script from which season it decided had the most relevant answer. Yeah, so there you go. We use OpenSearch a lot for this type of thing because it's a great component to have for the retriever part. And it means that these question answering models that are limited by a certain number of characters don't have to constantly go through all of the documents, but then we can use OpenSearch to hold our documents, and then in combination with a retriever model with a sentence similarity transform model, for example, we can get the most relevant top 5 documents, for example, and then that question answering model doesn't have to go through all of the documents and take a whole load of time. Instead, it takes a few seconds and gives you the top however many answers you requested from it. So there you go.
That was super awesome. What sort of questions do we have for Tuana?
Yeah, I have a question. Do you use the OpenSearch for the relevance calculation or just for the retrieval? Because I wasn't, I know you mentioned it's just retrieval, but based on the output, it looks like you have a score, and I wasn't sure where that score is derived from.
That score you saw is actually derived from the reader model. So that's only the question answering model. So that's by that point, OpenSearch document store has already returned to me the relevant documents that it thinks there are. But there are actually, like I said, it's built on the idea of nodes, and you can use certain things to like different algorithms to decide which ones are the most relevant documents. So in that scenario, you had the code example there that you saw was using a sentence similarity model alongside an OpenSearch document store. And I was using vector similarities on the documents I had and the query I had. And then OpenSearch was returning to me the top, I don't remember what it was, maybe top 10 documents that had the most similar vectors in that vector space. But then you can also decide, oh, I want to calculate the similarity based on keyword search. And then you can use, instead of the embedding retriever, you can use the BM25 retriever, for example, which is one of the most common keyword similarity algorithms.
Cool, thank you. And after you retrieve those, you do additional calculation of the score?
So yeah, so the let me share my screen again. I can go back to those slides, hopefully. So yeah, so the first step was the retriever here. It's the embedding retriever that returned to you top 10 documents that was most similar to the query you asked. And then there's a second step, which is what we call the reader step. That's the actual question answering model, looking at only those 5 documents that you said were the most relevant. So that's why we use this retriever reader pipeline. It's just because it makes it so much more efficient to run a question answering model. Instead of running it on all of the documents you may have, you then have to only run it on a few.
Cool, thank you. Just one more comment. I noticed that you have a flag, interesting flag there, use GPU. Was wondering if either your team or maybe someone in the community ever considered also enhancing the retrieving part with the GPU, or just...
Actually, that's a very good question.
Yeah.
It might be that there is a use GPU flag for this one, but I don't have an answer for that just now. But I think there might be. It feels like there has to be, because we're using yet another transform model here, a sentence. The embedding model that you see there is a sentence similarity model that we happen to be using for this retrieval step. So I'm assuming there is a use GPU flag for this one too, but don't quote me on it.
Thank you.
We had a couple questions that got dropped in the chat. Number one was, can you integrate with existing indices, which I think you had mentioned earlier.
Yeah, so this is why it's actually nice to talk about this now, because we have the function you saw, OpenSearch index to document store. What that's actually doing is you're saying, I already have all this text data in this particular index. And it means that you don't have to mess around with that. That text data remains the same. And then now take that and write to another one that I'll use in my QA pipeline, where you can do anything. Like you can create new embeddings for that text data. So instead of having it as pure text, now you have vector representations of that text. But it means that you can reuse a pre-existing database without having to rewrite documents yourself. Yeah.
Speaking of, so kind of adding on to that, then how do you deal with the security on existing indices? Like, are you integrated with OpenSearch's security model, or do you provide a different security model, or do people build their own?
I actually don't have a straight up answer for that, but I can get back to you guys on that. Actually, someone mentioned that we can open up a discussion on a forum, so this might be a good one for that one.
Yeah, we will have a post about this on the forum, so maybe that's a great place. We'll add that question in, we can get some answers on that. How do you deal with large documents? Like you mentioned, you're using whole transcripts. I mean, how difficult is that?
So the nice thing about Haystack is that it's designed on being able to do an NLP application end to end. And thankfully we have a pre-processing component. And when you write documents with Haystack to an index, what's actually doing is in the background, it's already indexing them to the format that Haystack can use later on. So they're all being sort of decoupled into Haystack documents. We call them documents where, it's a certain JSON object structure, basically. So when you write documents to an index for this purpose, that's already dealt with.
Nice. And then speaking of, so how do you handle the growing size of embeddings? Is it a distributed application?
Yeah, so this is another reason why extractive QA is quite nice, is because without having to retrain a whole model every time you have new documents, instead of that, you'll probably just have somewhere that depends on how you want to, architect your own application, really, but you can just say update embeddings every X period of times. And if you are using embeddings, that's how you would do it. So you'll initially start with your original set, and then once in a while, maybe check that there's something new and update embeddings. When you update embeddings, thankfully, that function won't duplicate everything you already have. It'll know and be able to check that you're not redoing everything that has to, that already was ready and done for you. Or you might be using just pure text without vector representations, in which case you would just use the indexing pipeline to convert that text data into that representation I was talking about.
Yeah. So the person who asked the question just actually said they were actually referencing the byte size. Do you have a way to reduce the embedding size and still keep good performance? That's deep.
Oh, I actually don't know, but I imagine this is something you could. I'm not sure. Again, don't quote me. I'm not an NLP engineer. I'm still learning along the way, but it feels like this is something you could choose your sentence transform model to. So when you say update models, what's happening is that sentence similarity model is creating vector representations with the same model for your query and all of your documents. So I imagine it's at this step where you might have the flex or choose one sentence similarity model over the other.
Interesting. Very cool. What other questions do we have? I'm going to ask one question. I already know the answer, but I think it's good for everyone to hear, because how are people using this, out in the world? I'm imagining not most people are using Game of Thrones to get question and answers, but what are some applications that you're seeing a lot of people using?
It comes, there's actually so many, but let's say you have documentation and you want documentation to be more accessible. We have people using this retriever reader pipeline only up until the retriever step, where you can have someone ask a question and it returns to you the most relevant documents in your database for it. So let's say you have documentation about OpenSearch and someone asks, what's something? And that something might be explained in 3 different places in your documentation, and you want to be able to make that accessible to people. That's one way of doing it. Another way of doing it is simple question answering. Let's say you're a government organization dealing with, I don't know, visa applications, and people are asking what document do I need to apply to XYZ, and you want to make that accessible to people, but you want to be able to show, let's say your QA model is super confident that the answer is something, and they can see where that something came from, but also maybe that's not the answer they're looking for, so you can see the top 10. We even have applications for FAQ matching, for example. So you may already have an FAQ out there, and you want to, someone might ask the question that's not exactly the same way as it's asked in that FAQ. And you might want to use a sentence up to a sentence similarity step, saying, okay, this question is most relevant to these 5 questions I have in my FAQ, and these are the answers for that. So there are lots of applications. And yeah, but then again, Haystack, this was just an example. Haystack is really built on this idea of nodes and pipelines, and this was about question answering, but we have similar things for summarization, like I said, FAQ matching, finding the most relevant documents, yeah, so much more.
No, that's super nice, being able to get that both the answer back and then where it got the answer from, so you can follow up with that. I think a lot of people kind of doubt when they're talking to a chatbot that it's giving them the right information or the most up-to-date information. So that's super cool. Any other questions?
I think so too.
I hope so. Awesome. Well, thank you so much for your time, and thanks for presenting that. Again, we'll have the slides and the follow-up in the forum. And with that, now we're going to be talking about something that is very interesting to me, because I came from a world that had lots of regulation, being in finance. So we're going to be talking about field level FIPS compliance, specifically FIPS 140-2 encryption with OpenSearch. And for that, I'm going to introduce Pakshi. Pakshi, would you go ahead and introduce yourself?
Yeah, hi there. Pakshi Rajan. I'm head of products, VP of products, and co-founder of a company called Titaniam. Titaniam brings encrypted search for OpenSearch, and we've been following the Open Distro for a while. We did this when the Open Distro plugin was available for Elasticsearch, and as soon as OpenSearch started happening as a separate project, we forked our code and we made the same offering work for OpenSearch as well. At a high level, Titanium is about adding encrypted search and privacy control for all your sensitive data. Oftentimes, you have extremely sensitive data that you want to be able to slice and dice through, and you are hesitating because the data is sensitive, and you may be in the regulated industry, and you are putting it in a clear text index may be something that you are banned from doing. So it happens a lot. It has happened in a company where I worked in the past, where I wanted to use this and I couldn't use it. So for that, what Titanium offers is a solution where you can encrypt everything, and we're not talking about file system encryption. And I'll show you quickly in a demo today that it's actually encryption at the index level before OpenSearch indices the data, and how you can actually run through most of your searches, not all, most of your searches through regular REST APIs without any changes to your queries. Obviously, it does require some re-indexing. We want to construct a homogeneous index unless you're talking about time series data. Time series indices. So that's the high level background. We also have data protection solution for AWS S3. We integrate to AWS Secrets Manager, which I'll show you in a second today. So we have full-fledged end-to-end protection for AWS Stack. So that's our overall background. We offer a number of other products. I don't want to spend time building the slide out. That's why I'm actually showing it to you in this form. And I'll be directly jumping into OpenSearch part. So we have a NoSQL store called the Vault. We have a plugin for OpenSearch, which is the hero of the story today. We'll be jumping into that. A proxy for protecting data on AWS S3, adding application level encryption. We have a translation service. And all of this uses a FIPS 140-2 compliant engine and key management, key rotation, the whole 9 yards. So everything you expect from an encryption shop. So at a high level, this is where I'm going to start building the slide. So at a high level, you have, why would you do something like this? Like you have, a range of threats that can manifest, admin privileges being compromised. Actually, just this last weekend, there was, I think, there was a headline I just read, 140 Elasticsearch clusters were compromised for I think, a ransom note for somewhere worth $500,000. Just like on Friday evening, I was just talking to someone and they mentioned it. In one attack, they compromised 150 clusters. And these things are not happening because like people are not taking precautions. It's happening despite of the precautions. Like some credential somewhere is compromised, or maybe there's a disgruntled employee, or so that's kind of how these things can start happening. We also can add privacy controls. I'll show you a slide on how that can be done. And then, of course, if you are running a SaaS operation, you can allow your customers to bring the encryption keys, which is often the demand these days. If you are running a SaaS, right away they ask, can we control the encryption keys? That's part of the RFP. And if you use the Haystack model, you can just say yes to the RFP question without any problem if you have the plugin from Titanium. Again, like I already said, no query changes, FIPS 140-2. And then how is it done at a high level? The Titanium protection for OpenSearch comes in the form of a plugin. And as the OpenSearch community already knows, the plugin is installed on every node of the cluster. And it encrypts the data even before the data is indexed or stored in the cluster. And everything else is works normally. And there's also conditional release, and I'll tell you how that is done at a high level. We have this translation service. So the search results from the plugin itself can be set up to be released either in clear text or in encrypted form. The most secure form is encrypted. So the plugin releases the data in encrypted form. It actually does all the searches in encrypted, like the reverse index, everything is in encrypted form, right? You you can't decrypt like terabytes of data in like a nanosecond and then do searches in clear text. So the searches happen in encrypted form. And then the question is, do we translate the results into clear text and release, or we release it as it is in encrypted form? Is like a configuration within the plugin. And most of the time, when I demo, I would release the data in encrypted form, and then I would have it translate as a separate step using a translation service. This translation service can also be installed like a proxy, so you don't have to make two separate API calls, one to OpenSearch and one to the translation service like this. The search results can be seamlessly translated on the way out. That can also be done. In fact, there are products. There's actually a product line. Anurag actually talked about observability platform earlier on. There are many products like that, like Exabeam. There are many like SIM kind of products in the market. There's one product by Palo Alto Networks called Cortex XOR. It's a product for SOC, and it uses OpenSearch, Elasticsearch as a backend. And again, we install our plugin and we add the translation service seamlessly, and then the product thinks it's actually working on clear text data. But if somebody steals the search indices, they're actually just getting garbage, right? Because it's all encrypted. So that's something that we add seamlessly for other companies' product lines seamlessly. I think we also have this notion of bring your own key. I was going to touch on this as the next slide here. We also have this concept called bring your own key, where if you are running a SaaS application on top of the search engine, and you have different customers are hosted in the same application. It's a multi-tenant application. Let's say you have two different indices for two different customers. You can have separate key store integration. So this could be in customer one's IT environment. This could be customer two's IT environment. There's a key registry, and we can read encryption keys from different places. So that your customers can actually hold the encryption keys. You don't have to hold them. I do have a bunch of use cases. I will share this slide. This is used by, so for example, like the OpenSearch example I saw was there's a company that has a lot of data on people in the US, and they, when people do background checks and stuff like that, they actually augment their data, the user profile with a query from this company, the case number 3, and they have basically, on the 300 million people in the US, they have at least like on an average about 15 data points, and so they want to be able to do fuzzy searches. They wanted to, like, if somebody spells Catherine the wrong spelling, they want to be able to use the phonetic plugin. They want to use Levenshtein distance to identify the person, so that we're not missing out on false negatives. And they asked, can you encrypt and still do can you encrypt the data, the index, and still have all the fuzzy searches working? And we could really get the phonetic one working right away, and we added the Levenshtein distance to our roadmap, which we don't have today. But that part we could show right away, and like they really had no other option except encryption, because they were in a regulated space already, and they were actually getting bought by another company that was even bigger and even more regulated. And so they had to, like, the acquisition had to go through. They had to encrypt the index, otherwise, that acquisition wouldn't go through. So they had no choice. This was like a must-do for them. There were a lot of other use cases I can share outside of these case studies, but these are some of the case studies we have. And the one thing that I'm noticing is that a lot of companies are moving from like Elasticsearch to OpenSearch after the license change. This is happening like an exodus. So we have a plugin for Elasticsearch as well, but OpenSearch is kind of where I see the wind blowing for a lot of my customers. The first two companies here, they're also, they were originally on Elasticsearch, but now they're moving towards OpenSearch. So that's the high level intro. I do have some actually, yeah, let me actually just share this slide. This is probably useful. I said earlier that everything that you store will be encrypted. So this is an example of how the index will be created, the reverse index will be created. But then when we release the data, we can say that the HR analyst should be able to analyze the data in the search results, for example, and but they don't need to see the identity of the person. Whereas the head of HR should be able to see all the data, maybe the legal team should just be able to get the contact, but nothing else, right? So we can actually just layer in privacy enforcement on top of the search results that comes out of OpenSearch seamlessly as part of the whole thing, right? So then I have some data points. The search ingest overhead. We are at about 10% over here right now at the ingest time. So if you have 10 nodes for ingesting data, you probably want to have 11 nodes because we do take extra 10% overhead in the ingest time. And the search overheads are all less than 5%. Most of the time it's 2 to 3%. But I'm just being conservative, saying it's less than 5%. And today we support these 5 types: keywords, text, numbers, IPs, and date time. With numbers, we support integers. We don't support longs and booleans yet, but we do plan to expand this the suite of data types for protection. And the geo data type has been in the OSC for a long time. So yeah, I mean that's the portfolio of what we have. So let me just jump over quickly to the product and then show you how this works. So normally, like, this is the community where I don't have to introduce this product, right? Most of my customers, I tell them this is OpenSearch Dashboards, it's a REST API client, etc. But here it's my pleasure to bring this product up and show the demo. Normally, people index data in clear text. It's not very different from this. You have an index template, or you have you create an index by hand, and the data, in this case, I'm using very sensitive HR data. You have first name, last name, their annual salary, date of birth, etc. And oftentimes, this is the kind of index you need to actually be able to slice and dice the data to wire up maybe a HR application in front of OpenSearch. Once you install our plugin, and our plugin is installed on this cluster, let me just show you that. This is the Titanium plugin. Excuse me. This is the Titanium plugin where we haven't replaced the number yet, so this is a bug. We have to fix it. So this plugin is installed. Once you have the plugin, you can tell which version is running, etc. Where is the seed store for this plugin? It's a custom API endpoint. Then once you have that, then you can actually create your index like this. This is the same index that we saw a little bit earlier. This is employee 000, all clear text. All clear text. You can see here. It's employee 001 is all encrypted index, right? So this is the encrypted index. Now you can also, like, when you actually create the index, you normally would use, like, for 000, whether through index template or like directly using an index put, you actually would use data types like keyword, date, and integer. That's just how normal indices are built. With Titanium, you would actually use data types that we specify. Like, this is what the plugin introduces, this more secure data type. And here the first name is built using tangled, tiny keyword tangled. It basically says that it's going to be stored encrypted. It's a type keyword, and the search results are going to release it in encrypted form, right? That's kind of the prefix, data type, and suffix format. How is it protected? How is it released? So that's like, you can see there's actually a bunch of data types. There's also like a pipeline that we built that works in line with this. These are the data pipelines. The ingest processor, for ingesting this data. So once you have this, right, then you can actually do like regular searches. Like, you're normally doing a search. Let's say, give me all the people whose last name is Daleman. Well, this is last name Daleman, and you can see that the source document is salted, whereas the reverse index underneath it is not salted. Therefore, you can see, like, if somebody steals this data and they looking for frequency attack on this, right? This is Dalemon right there that ends with a DOR F6F, and this is EH86RP. They're all Dalemons, right? So the source document is immediately salted, so you don't get any frequency attack. But if you want to translate this, like you can copy the content of this, and then you can go to the translation service I had in my picture. It's running as a REST API, and I'm just going to put this query here, format it. And this tool is called Postman. It's a REST API query for general purpose REST API, like Kibana for like OpenSearch Dashboard for OpenSearch, right? So here you can see that these are all people with last name Dalemon, even though the search results didn't have common last name in any of this. This is the last name. If you select this, it doesn't select here, but to select Dalemon, it selects other Dalemons because it's all the same word. So you can do other searches, like you can do like wildcard searches, like last name that ends with an LEMAN. So obviously this should contain document ID 1, which we saw. Where is document ID 1? ID, yeah, 1, 2, yeah, it has got a bunch of documents. So these are all last name Dalemons, last name LEMAN. You can also do this exact same query on the clear text index. That's another way you can actually just verify right there. You should get the same documents 12815, 18215, etc. 18215. These are all last name that ends with an LEMAN. Or you could actually just do the same translation. Like you can, take this result and translate it, and that's how your application would actually see the data. Like if you're building an application, the translation service would actually translate, and so that the web interface can actually be drawn after the translated result, not the raw search result. So anybody stealing data from like OpenSearch, let's say your admin password is compromised, they're actually going to steal this, and there's nothing to worry about. You can actually, if you have auditors asking what was taken, you can just say, well, it's all encrypted. Like I said earlier, most of the queries work. We kind of like make sure that we actually show a good amount of queries working in all our demos, POCs, etc. But we always tell our customers to make sure that test your queries before you actually buy the product. So we give enough time for customers to verify that all their queries are working up to 30 days. And if this is all working, then then you can buy the product. So we usually do try before you buy. Here is what the other customer was doing. You can see, like I'm doing a zero, like on this employee 001, which is an encrypted index, looking for all the people whose name sounds like Catherine. This is exactly from my use case. And here I've installed the phonetic plugin that comes as part of the OpenSearch distro. I copy this result and then I go to my translation service. And then I can translate to JSON. And you can see these are all names that sounds like Catherine, but not spelled like Catherine. Maybe there's actually one Catherine here as well. But if you are doing customer support on the phone and they're typing, they are saying the word wrong, spelling the word wrong, this kind of search could still be done with encryption. So that's the high-level demo. You can do like, Los Angeles spelled wrong, employee 001. There are 5618 results because I'm searching in the sounds like field, the subfield of the city. But you'll see the same 5618 if you spell it right on the main field. So you can handle the typos on search results, search queries, etc. So that's the high level. I'll stop sharing and then see if there's any questions from audience. There's a question, super useful piece, which OpenSearch is lacking right now. The Titanium plugin is a commercial product or is it OpenSearch? We are a commercial product. We do support longer trials if you want to see. But yeah, we are a commercial product.
Adding on to that, yeah, adding on to that question, actually, it looked like you had your own custom plugin. So do you see most people using this with their own rolled OpenSearch, or is it with managed services? How does that kind of play out?
Awesome question. At this point, the AWS managed OpenSearch does not allow plugins to be installed. With Elasticsearch, managed Elasticsearch, they opened up like about 9 months ago. Well, 7 months ago, they opened up installing custom plugins, and I have put in a request with Eli and other teams that are like managing the OpenSearch, even the managed OpenSearch, Carl Meadows. I've reached out to him to ask for adding custom plugin support for managed OpenSearch, and I was told that it's coming this summer. So I'm really excited and waiting for that to come, so that we can test and certify it. But right now, unfortunately, if you want this plugin, you have to install OpenSearch on EC2 and or EKS and manage it yourself. We also work with a number of partners. Actually, they are all highlighted on your partner portfolio. There's a company called Ivan, AIVEN. There's a company called Bonsai, BONSAI. These are people who run OpenSearch as a managed service, and they actually give amazing white glove service. If you use one of them, they also can install our plugin and then run it for you. We have actually Bonsai running it for us in some production instances at a bank, and they do amazing job, really stellar service. But at some point, I think we will be able to support this at the managed OpenSearch as well.
Awesome. That's phenomenal. Another question that just came in. So Samuel Herman said, are there any aspects of search that are impacted as a result of the encryption? So any portions that are unsupported right now?
Yeah, so regex search we didn't implement because we thought that it gives away a lot. It just the whole spirit of doing encryption kind of falls apart if you do a regex search. There are also a couple of other searches. So we actually derive encryption keys on a per field basis. So if the same value comes on all the fields, we actually don't use the same encryption key, which means that when you're searching across all the fields, let's say you're trying to search, let's say the 1,000 fields in your index, and you're just doing a search across any field, those searches will not work because we have to customize the search term for each field to be queried against. Multi-match, we can make it work because we know exactly how many fields you're searching, but searches across all the fields, you'll have to decompose that into a Boolean should search, and then that way it would execute. So there are minor things like that. And then I always add this as a disclaimer saying we don't know what we don't know, because OpenSearch has got super large surface area, and if there is something that doesn't work, we will do our level best to make it work. So our goal is to make sure that you don't have to change your search queries. So that's our ideal goal. Yeah, and then performance, you saw in all the searches I did were pretty zippy, and I don't have a lot of documents. I have only maybe 500,000 documents in my index, but it's comparable speed almost in the search. Thanks,
that was
Samuel.
phenomenal. Yeah, this is so cool, actually. And I know how difficult FIPS compliance is. And this is the first time I've actually seen it as a front end, a front side service coming in. A lot of people try and deal with FIPS, from within the application itself. I've seen people, modifying their Java runtimes to be able to try and be FIPS compliant. So it's super challenging. So I see this. One other question. Let's see. How does this compare to the encryption at rest that is recommended in the OpenSearch docs?
Yeah, really good question. This comes up quite a lot, actually. Now, I think encryption at rest should be used no matter what, because this is, what Titanium does is it encrypts before it intercepts the data before it the OpenSearch ingest process even takes over. So everything is encrypted upfront, and so the index, the reverse index, everything in memory is also encrypted, which is a very important part of FIPS. If somebody does like a heap dump, they shouldn't be able to get anything in. They shouldn't get the encryption keys. They shouldn't be able to get any data, any of them in clear text. That's a requirement for FIPS 140-2. If you are in the regulated industry, that's a requirement. So what the product does is it actually encrypts everything before OpenSearch indices it, right? So if you're adding the file, the rest encryption at rest, you are now encrypting encrypted data, which is, a second level of encryption, which, it doesn't actually add a lot of overhead, so you should actually do it. But even if you didn't encrypt it at the file system level, you would have encryption because everything that's coming through the Titanium processor is already encrypted. So from a net result point of view, what's the difference, right? So the encryption at rest works if somebody, let's say you have an attacker in your organization and they are able to get to the file system. Let's say you have mounted some EBS volumes where you're writing the Elastic index, the OpenSearch index. And if they actually get their hands on the OpenSearch, the index, the location, the file system location where the OpenSearch index is written to, and if that's what they're stealing, then the file system encryption would actually, thwart that attack. But if somebody had access to the REST APIs, let's say an admin credential is, let's say you have an application that's querying OpenSearch and it has a service account, and that service account is compromised, for example. The encryption at rest doesn't really do anything for it because you are like, the REST APIs are going to release the data in clear text. With Titanium, what you just saw was that you're actually sending in clear text queries. Even the search results come in encrypted form. And we're not just encrypting the search results. The search was actually happening in encrypted data, and we're just getting the results as it was actually stored in the product. Then you're actually translating it explicitly using a translation service. Now that is a simple RESTful service where you can add all kinds of limitation. You can have rate limiting. You can have, it's like anything that you would add on top of an API gateway, or like Amazon has a bunch of them. You can actually throw in and then do a lot more tighter enforcement, like maybe 25 documents at a time or 50 documents at a time, limitations, unless you have a special token, all kinds of limitations, so that you will never lose your entire index in one shot. Like if somebody has, compromised the admin credentials of a cluster, you risk exposing all your data in one shot. That will never happen once you have this plugin and the translation service.
Wow, this is like some really powerful stuff.
Yeah.
With that, I'm going to say thank you so much. I'm going to pause questions for just a minute so we can wrap up the meeting. If anyone does have more questions though, we'll hang around for a short bit afterwards. Also, there will be the forum post on this. Thank you so much, Pakshi. This is really cool.
My pleasure. Thanks for the opportunity.
Absolutely. So with that, a couple just brief community, announcements. So we do have the save the date. OpenSearchCon is coming up September 21st. If you have not registered, you should go ahead and do so. We'll link that in the chat, hopefully. Also, follow our official social handles. That's where you'll hear first about about our new community meetings, what's going to be presented. So definitely follow those along. Also, yeah, that's a good call out. Thank you, Chris. The CFP closes tomorrow, so that's the call for papers. If you have, and Pakshi, I would like to invite you to submit this if you haven't for OpenSearchCon, because we'd love to hear about it more. But yeah, so submit your papers and check that out. We have Berlin Buzzwords that is going on actually next week. That's right. Wow, that is very fast. So Berlin Buzzwords is coming up. Same with OpenSearchCon, and we will see you next time. Our next meeting is an open office hours. So that's for open question and answer session. That's going to be June 13th. And then June 21st is going to be our next community meeting where we have, regular presenters and things along those lines. So thank you so much, guys.
Thanks, everybody. Always awesome meeting. Thank you very much. Yeah, I have submitted the paper for September. I'm really looking forward to it, David.